Hello and welcome to the show, where we dissect the future today. The Consumer Electronics Show, CES, has once again set the stage for a torrent of innovation, and as always, Nvidia has managed to capture the spotlight. Their CES 2026 keynote wasn't just a product showcase, it was a declaration of their vision for the future of computing, a future that is increasingly autonomous, intelligent, and seamlessly integrated into our lives. Today, we're going to unpack everything Nvidia announced, from the silicon that will power the next generation of AI to the software that will bring it to life. We'll explore not just what these technologies are, but what they mean for the trajectory of artificial intelligence and computing as a whole. Let's start with what many are calling the ChatGPT moment for physical AI. Nvidia CEO Jensen Huang unveiled Alpa Mayo, a groundbreaking family of open-source reasoning models designed to guide autonomous vehicles through the complexities of real-world driving. This isn't just another incremental update to their AV stack. Alpa Mayo 1, a 10 billion parameter chain of thought system, represents a paradigm shift in how autonomous systems perceive and interact with their environment. Instead of simply reacting to sensor data, Alpa Mayo breaks down unexpected driving situations into a series of smaller, manageable problems, and then determines the safest path forward, all while being able to explain its reasoning process. This transparency is crucial. For years, one of the biggest obstacles to widespread adoption of autonomous vehicles has been the black box problem. When an AI makes a decision, especially one that could affect human safety, we need to understand why. Alpa Mayo addresses this head-on by providing a clear chain of thought, allowing engineers, regulators, and eventually passengers to understand the logic behind every maneuver. To complement this, Nvidia also introduced Alpa Sim, a simulation platform for training these models on rare and dangerous scenarios in a safe, virtual environment. The importance of simulation cannot be overstated. Real-world data is invaluable, but it's also limited. You can't ethically or practically expose a vehicle to every possible edge case on public roads. Alpa Sim allows developers to create and test scenarios that might occur once in a million miles, ensuring that when they do happen in reality, the vehicle is prepared. The 2025 Mercedes-Benz CLA is slated to be the first vehicle to feature this entire suite, a testament to the industry's confidence in Nvidia's approach. This isn't a concept car or a distant promise. This is a production vehicle that will be on roads soon. By open sourcing Alpa Mayo, Nvidia is not just providing a product. They are cultivating an ecosystem, inviting developers to build upon their foundation and accelerate the journey towards a fully autonomous future. This open approach is strategic. By making their technology accessible, Nvidia ensures that their platform becomes the de facto standard, much like CUDA did for GPU computing. But what powers these incredible AI models? The answer lies in the heart of Nvidia's hardware innovation, the Vera Rubin Supercomputer platform, named after the pioneering astronomer who provided evidence for dark matter. This next-generation architecture is a marvel of engineering. Each Vera Rubin system combines a Vera CPU with 88 custom Olympus cores and a staggering 1.5 terabytes of system memory, with 2 Rubin GPUs, each packing 336 billion transistors. To put that in perspective, the human brain has approximately 86 billion neurons. We're talking about chips with nearly 4 times that number of transistors, each one a tiny switch capable of performing calculations at speeds that would have been unimaginable just a decade ago. The result is a system that is 3.5 times faster for training AI models and 5 times faster for inference compared to the already formidable Blackwell architecture. These aren't marginal improvements, these are generational leaps. What's truly remarkable is the co-development of the CPU and GPU, a design philosophy that ensures they work in perfect harmony, maximizing efficiency and performance. In traditional systems, the CPU and GPU are designed independently, and then engineers work to make them communicate effectively. With Vera Rubin, Nvidia has taken a different approach, designing both components from the ground up to work together. This means less time spent moving data between components, less energy wasted on inefficient communication, and more time spent on actual computation. Nvidia has also re-engineered the physical design of the blades, creating a more streamlined and reliable system with fewer cables and components. This might seem like a minor detail, but in a data center with thousands of these systems, reducing cable clutter and potential points of failure can have a significant impact on reliability and maintenance costs. While these systems are initially targeted at hyperscalers, the tech giants who operate massive data centers. The advancements they represent will eventually trickle down to a wider range of applications, fueling the next wave of AI-powered discoveries in fields ranging from drug discovery to climate modeling. Now, let's shift gears to the world of gaming, a domain where Nvidia has long been a dominant force. At CES 2026, they unveiled DLSS 4.5, the latest iteration of their AI-powered upscaling technology. Trained on a second-generation transformer model, DLSS 4.5 promises to deliver even more stable and visually stunning images with significant reductions in ghosting and shimmering. These artifacts have been the bane of upscaling technologies for years. When you're trying to generate a high-resolution image from a lower-resolution source, it's easy to introduce visual glitches, especially in scenes with a lot of movement. DLSS 4.5 tackles this problem with a more sophisticated AI model that understands the temporal relationships between frames, allowing it to predict and generate pixels with greater accuracy. But the real game changer is the introduction of 6x multi-frame generation. This allows a 50 series GPU like the upcoming RTX 5090 to generate 5 frames for everyone that is traditionally rendered. Think about that for a moment. The GPU is doing 1/6 of the traditional rendering work, and AI is filling in the rest. Imagine playing the latest AAA title in 4K at a silky smooth 240 frames per second. That's the level of performance DLSS 4.5 aims to unlock. For competitive gamers, this is a massive advantage. Higher frame rates mean lower input lag and smoother motion, giving you a split-second edge that can make the difference between victory and defeat. For everyone else, it's simply a more immersive and enjoyable experience. Furthermore, dynamic frame generation intelligently scales the number of generated frames based on the complexity of the scene, ensuring optimal performance and efficiency. In a demanding scene with lots of explosions and particle effects, DLSS 4.5 will generate more frames to maintain smoothness. In a quieter scene, it will scale back, conserving power and reducing heat. This isn't just about making games look better, it's about fundamentally changing the way we experience them, blurring the line between the virtual and the real. To complement these advancements in rendering, Nvidia also introduced G-SYNC Pulsar, a new display technology that promises to eliminate motion blur and deliver unprecedented clarity. By pulsing the display's backlight, G-SYNC Pulsar achieves a perceived motion clarity equivalent to a 1000 Hz refresh rate. Now, you might be thinking, don't we already have high refresh rate displays? And yes, we do. But there's a difference between refresh rate and motion clarity. A traditional 240 Hz display refreshes the image 240 times per second, but each frame is displayed continuously until the next one arrives. This creates a slight blur, especially in fast-moving scenes. G-SYNC Pulsar addresses this by pulsing the backlight, effectively creating a strobe effect that reduces the persistence of each frame. This means that even in the most fast-paced action sequences, every detail will remain sharp and clear. It's like the difference between watching a movie on film and watching it on a high-speed camera. The first G-SYNC Pulsar displays will also feature the ability to automatically adjust their brightness and color temperature to match the ambient lighting, ensuring a comfortable and immersive viewing experience in any environment. This might seem like a small feature, but anyone who's ever strained their eyes gaming in a dark room or struggled to see the screen in bright sunlight will appreciate it. It's a testament to Nvidia's holistic approach, where every component of the gaming experience from the GPU to the display is meticulously optimized for performance and quality. Nvidia's cloud gaming platform GeForce Now also received a significant expansion at CES 2026. With native apps for Linux PCs and support for Amazon Fire TV, GeForce Now is becoming more accessible than ever. For years, Linux users have been somewhat left out of the gaming ecosystem, often having to rely on compatibility layers or dual booting into Windows. With native GeForce Now support, they can now access the same library of high-end games as everyone else, streamed directly to their machine. Similarly, Amazon Fire TV support brings high-end gaming to the living room without the need for a dedicated console or gaming PC. The addition of flight control support opens up a whole new genre of gaming to the cloud. Flight simulators are notoriously demanding, both in terms of processing power and peripheral support. By adding flight control support, Nvidia is signaling that GeForce Now is ready to handle even the most specialized gaming experiences. And the continuous addition of new AAA titles ensures that there's always something new to play. This expansion underscores Nvidia's commitment to making high-end gaming accessible to everyone, regardless of their hardware. You don't need a $1,000 GPU to play the latest games at maximum settings. You just need a decent internet connection and a GeForce Now subscription. While not featured in the main keynote, Nvidia also quietly announced the next generation of their Jetson edge devices, the T4000 and T5000. These powerful yet compact systems, with up to 128 gigabytes of RAM, are designed to bring AI inference to the edge, enabling a new class of intelligent devices. The T5000 is even capable of running large language models like OpenAI's GPT-OSS 120B, opening up exciting possibilities for on-device AI applications. Think about what this means. You could have a robot that understands natural language and can respond intelligently, all without needing to connect to the cloud. You could have a security camera that not only detects motion but understands what it's seeing and can alert you to specific threats. You could have a smart home assistant that truly understands context and can anticipate your needs. This is a crucial piece of the puzzle in Nvidia's vision for a world where AI is not just in the cloud, but all around us, embedded in the devices we use every day. So, what does all of this mean? What is the big picture that Nvidia is painting for us? It's a future where AI is not just a tool, but a partner. A future where our vehicles navigate the world with superhuman awareness, where our games are indistinguishable from reality, and where intelligence is embedded in every device we interact with. Nvidia is not just building chips, they are building the foundations of this future. Their full-stack approach, from silicon to software to simulation, gives them a unique advantage in this race. They're not just selling you a GPU, they're selling you an entire ecosystem, a complete solution that works seamlessly from the data center to the edge. By open-sourcing key technologies like Alpa Mayo, they are fostering a collaborative ecosystem that will accelerate innovation. They understand that the future of AI is not something that can be built by one company alone. It requires a global community of developers, researchers, and engineers all working together. The announcements at CES 2026 are not just about faster processors or more realistic graphics. They are about a fundamental shift in how we interact with the digital world, and ultimately, the physical world as well. The ChatGPT moment for physical AI is not just a catchy phrase, it's a glimpse into the future that Nvidia is building, one transistor at a time. We are standing at the precipice of a new era, an era where the boundaries between the digital and the physical are increasingly blurred, where machines can reason, learn, and adapt in ways that were once the exclusive domain of human intelligence. And Nvidia, with its relentless focus on innovation and its commitment to building the tools that will power this future, is leading the charge. The question is not whether this future will arrive, but how quickly and how we will adapt to it. Let me dive deeper into some of the critical implications of these announcements, because there's so much more beneath the surface. When we look at Alpa Mayo and the autonomous vehicle revolution, we need to understand the broader context. The autonomous vehicle industry has been in a state of flux for the past few years. We've seen bold predictions fail to materialize, we've seen accidents that have shaken public confidence, and we've seen companies scale back their ambitions. What Nvidia is offering with Alpa Mayo is not just better technology, it's a new approach to the problem. The reasoning model architecture is fundamentally different from the end-to-end neural networks that many companies have been pursuing. Instead of training a massive model to learn everything from raw sensor data to steering commands, Alpa Mayo breaks the problem down into discrete reasoning steps. This modularity makes the system more interpretable, more debuggable, and ultimately more trustworthy. The open source nature of Alpa Mayo is also strategically brilliant. By giving away the model, Nvidia ensures that it becomes the foundation upon which the entire industry builds. Developers will create tools, frameworks, and applications around Alpa Mayo. Universities will teach courses using it. Startups will build businesses on top of it, and all of this activity will reinforce Nvidia's position at the center of the autonomous vehicle ecosystem. It's the same playbook they used with CUDA in the GPU computing space, and it worked spectacularly. Now they're applying it to physical AI, and the results could be even more transformative. The Vera Rubin platform represents another critical inflection point. We're now at a stage where the computational demands of AI are so immense that traditional architectures are hitting their limits. The co-design of CPU and GPU is not just an optimization, it's a necessity. As models grow larger and more complex, the bottleneck is increasingly not the computation itself, but the movement of data between different components. By tightly integrating the CPU and GPU, Nvidia is addressing this fundamental challenge. The performance improvements we're seeing 3.5 times faster for training and 5 times faster for inference are not just the result of more transistors or higher clock speeds. They're the result of a fundamental rethinking of how these systems should be architected. And let's talk about the implications for AI research. With systems this powerful becoming available, we're going to see a new wave of breakthroughs. Models that were previously too large or too computationally expensive to train will suddenly become feasible. Researchers will be able to experiment with new architectures, new training techniques, and new applications that were simply not possible before. We are likely to see advances in areas like protein folding, climate modeling, materials science, and drug discovery. These are problems that require massive computational power, and Vera Rubin provides exactly that. In the gaming space, DLSS 4.5 and G-SYNC Pulsar represent the maturation of AI-driven graphics. We've moved beyond the point where AI is just a nice-to-have feature. It's now central to the entire rendering pipeline. The 6x multi-frame generation is particularly fascinating because it represents a fundamental shift in how we think about rendering. For decades, the goal has been to render every frame as accurately as possible. Now, we're saying let's render one frame accurately and let AI generate the rest. This is only possible because AI has become so good at understanding the temporal and spatial relationships in video. The transformer models that power DLSS 4.5 are essentially the same architecture that powers large language models, like GPT, just applied to a different domain. This cross-pollination of ideas between different areas of AI is one of the most exciting aspects of the current moment. G-SYNC Pulsar's backlight pulsing technology is also more significant than it might initially appear. Motion clarity has been one of the last remaining barriers to truly immersive gaming. We've solved resolution, we've solved color accuracy, we've solved refresh rate, but motion blur has persisted. By achieving perceived 1000 Hz motion clarity, Nvidia is essentially eliminating this last barrier. The result is a visual experience that is closer to reality than anything we've seen before. And when you combine this with the photorealistic graphics enabled by DLSS 4.5, you get an experience that is truly transformative. The expansion of GeForce Now to Linux and Amazon Fire TV is part of a broader trend towards platform-agnostic gaming. The traditional model of gaming, where you need specific hardware to play specific games, is breaking down. With cloud gaming, the hardware becomes irrelevant. You can play the latest AAA title on a cheap laptop, a tablet, or even a smart TV. This democratization of gaming is going to have profound effects on the industry. It lowers the barrier to entry for new gamers, it extends the reach of game developers, and it creates new business models. Nvidia is positioning itself at the center of this transformation, and GeForce Now is their vehicle for doing so. The Jetson Edge devices, while less flashy than the other announcements, may be the most important in the long run. The ability to run large language models locally, without needing a connection to the cloud, opens up entirely new categories of applications. Privacy-sensitive applications, where you don't want to send data to a remote server. Latency-sensitive applications, where you need an immediate response. And applications in environments where connectivity is limited or unreliable. The T5000, with its 128 gigabytes of RAM, is powerful enough to run models that were, until very recently, only accessible through cloud APIs. This is going to enable a new generation of intelligent devices. From robots to drones to industrial equipment, all capable of sophisticated reasoning and decision-making at the edge. When we step back and look at all of these announcements together, a clear picture emerges. Nvidia Mayo is building a complete AI computing stack, from the most powerful supercomputers in the world down to the smallest edge devices. They're providing the hardware, the software, the tools, and the ecosystem. And they're doing it in a way that is open and collaborative, inviting the entire industry to build on their foundation. This is not just a product strategy. It's a vision for the future of computing. And based on what we've seen at CES 2026, that future is arriving faster than many people realize. The age of physical AI, where intelligent machines interact with and shape the physical world, is no longer science fiction. It's happening now, and Nvidia is at the forefront. Thank you for watching, and I'll see you next time.